Okay, we're looking at 5.2.4. We're going to use the corollary to Fermat's little theorem, which is on page 87, and it says that A cannot be 0 mod P. So in the book, I believe there's a typo. It should say A cannot be 0 mod P. Then A to the P minus 1 is equivalent to 1 mod P. So we have A to the P minus 1 is equivalent to 1 mod P. And we can only do that if A is not equivalent to 0 mod P. Okay, so what we're going to do first here is look at this and then just plug in a 0. So I'm looking here, and sure enough, if we plug in a 0 to that, then we get 0 plus 0 plus 5 is equivalent to 0, which is not true, which is not a solution, so we're not interested in that 0 value. So let's go ahead and continue. So we're considering all the other possibilities. Now, what I did is I just used Fermat's little theorem here. And so this right here is 6 times 6 multiplied by itself 7,777 times, right? So I went ahead and took out a 6 just to see what would happen. And I took out a 6, and then I was able to create this just using simple algebra, make this. And then you can find that this right here, this x to the 6th is actually 1 using Fermat's little theorem, right? Mod, we're talking about mod 7 here. So that's just going to be 1 mod 7. So from there, we can just say this whole thing is 1, and then we end up with this right here, finally with this, and then remember, again, we're considering all values but 0. So there we go. X is equivalent to 1, and that agrees with back of the book as well. Let me check that one more time now. So 5.2. Oh, no, actually, no, I checked this on just manually. I plugged in 1s, and that's what works. So 1 to the 6th is 7777 plus 1 plus 5. This is 7, which is equivalent to 0 mod 7. Yeah. All right.